Hello everyone and welcome to the last session from day one of our digital V-Days. My name is Götz and I will moderate this webinar today. We are very pleased that you took the time to participate in our webinar. Our speaker today is Götz Schattmann, who is working as a field application engineer at Würth Elektronik eiSos. Götz, hi.
Hi, Silas.
Cool to have you here. Before we start with the webinar, I would like to give you some more information. First of all, you will be muted during the webinar today. This means that you cannot ask us questions via your microphone, but you have the opportunity to ask your questions to the chat in the chat function. The webinars will be about 30 minutes long, and after that we will start a short Q&A session, and then we will answer your questions. If we are unable to answer all your questions within this time, Götz will answer them via email in the next days. So last information from my side, you will all receive the link to the recording as well as to the presentation in the next days. So now I will hand over to you, Götz, and I wish you an exciting webinar. Thank you.
So, thank you, webinar. Thank you, everyone outside there, and thanks, Silas, for the nice introduction today. And yeah, nice you all be here joining us today. And the title today is Smarter Designs with SMT SPACERs, and I guess some of you already know these kind of parts. Yeah, so maybe we can give you some more ideas about it. So let's jump into that. And yeah, here's the main question I have to you. And well, this is the first positioning. Yeah, maybe you know some of the big furniture makers coming from Sweden. Yeah, and yeah, assembling PCBs together maybe is not exactly the same task. Even due to the fact that it's much smaller, doesn't mean necessarily that it's much easier. Even especially when it becomes very small and tiny, then it can become really tricky. Yeah. So today we're going to talk about the SMT SPACERs and how they can bring benefit to you, and maybe you will get some more ideas about it. Small introduction about the SPACERs, and let's look into detail about the different SPACERs that we can offer, also about the design and processing, what you have to take care about, and some application examples, and then we also have a economic comparison for you. So yeah, history of SPACERs, everybody knows these kind of SPACERs here. You just screw them together. And they are really commonly used and widely used in electronics field. You can build almost everything with it in the Lego style, and you can achieve different board-to-board heights, of course, or just fix PCBs or any other component into your appliance or onto a PCB. Yeah. So you really have a very wide variety of different components. And of course, they offer great flexibility. You can do what you want. And at the end, it's also very stable, very rigid, and you can build very solid designs with it. Yeah? You see some samples here on the bottom. And yeah, everybody's using them. I guess almost every one of you already used it. Now, due to the fact that we have all these good arguments, there is the question if there is any obstacle, and maybe it's also obvious to you that, of course, it uses a high manual effort to use them. Yeah? Means the handling can be really difficult, and I brought some samples here to you today. So if you look at this sample board here, and very typically, yeah, you want to open a spacer or you want to mount a spacer, then of course you need two hands. A third hand would be helpful, yeah, to hold the PCB if it's not standing like this. And yeah, that means it's very time consuming. You need a tool, you need a counterpart, you need the screw, and that all takes a lot of time. And also, what you have to bear in mind is that before you can use the parts, you also have to buy them. You have somebody in the warehouse have to put it on the shelf. Then you have to draw it from the shelf once you need the parts. So all this, all the logistics also means some effort. Yeah? And at the end, it is a costly solution. Yeah? So that's what made us think, and we're thinking about how we could achieve a better handling with less manual effort and first of all, more cost efficiency. So the solutions, of course, it's there. It's the SMT SPACERs, and they have been in the market quite for a while. But there is still a lot of potential out there to use them, and this is what this training is about. So if you look on this this slide here, you can see on this board that there is already 2 of the spacers installed, and we have another board which comes here on top, and here you see it in a mounted version, and those 2 screws are now fixed to this assembly here. And that makes it really easy and convenient. So what is the general benefits of the solderable SMT spacers? You can see the schematic here. First of all, it's the automatic assembly. And automatic means you get them delivered in a type and reel packaging on big wheels, and you can put them on a pick and place machine, and the pick and place machine just doesn't care if it's a resistor or capacitor or even an SMT spacer. So therefore the installation is very fast and very precise, and therefore you get really highest process reliability, means you have always the same effect. You will end up with strong holding forces and torques, and of course you also here have a large selection of types and shapes, starting in heights from only 0.5 millimeters up to 16 millimeters in total. The limitation there is necessary because the height of the tape here, the cavities in here can't be endless long, so therefore we are limited here in space. Otherwise you would get maybe 30-40 pieces on a reel. That doesn't make sense at the end. Yeah? So further, there are threaded versions, like you can see here. There's a typical thread, but you can also have internal thread, but you can also have internal through hole that you just push a screw through it. Yeah? And we have the vertical types, as you can see here, all vertical oriented, but we also have the right angle types. And what you see here in this corner or even here is some special mounting solutions, and we'll go here more in detail. But additionally, what's interesting for you, if you need a special length which is not inside the scale of our standard portfolio, then you can ask for any dimension that you want, especially in height. Yeah, we can produce it for you. Of course, you have to watch out for the minimum order quantity. However, it's not too expensive, and of course there you can order them as you need them. Let's start with these types. This is the type with the external thread. It's commonly only in M3 available. So you see the type here on the PCB, a little demo PCB. And So this is the one with the external. So I hope you can see it. Yep. It's the one with the external thread. And yeah, it's very easy then to put a second PCB here on top. I have a sample here that I can show you. So just put the PCB on top and you can mount your screw on top. Second type would be the one with the inner thread. So can't see it inside here, but we have that with an inner thread, of course. Then you can also put the second PCB on top and use a second screw, or use a screw and then fix it with a screw inside here. So it's almost the same like we have here on the bottom. So the next point here is that we have the reverse type. That's this type. You can see it here right on the edge of the PCB. Maybe I can show it from there. If I turn it a little bit. So you can see that it makes the distance here to the bottom, to the ground. And the idea for this is, especially if you are using a single-sided PCB, that means you only have your components on one side of the PCB, then you can use those to achieve a distance to the bottom height, or to the bottom PCB, or to the ground, to an enclosure, if you have a ground plate where you want to mount it. And yeah, the benefit or the main argument is that you don't need a second reflow process. So you just assemble it from the top and you solder it also from the top, but it makes you a distance to the bottom side. Yeah. So which one else we have? We also have the right angle types here. We have two different types of in right angled. Hope we can see them here. Pretty good. So they have a little bit different dimension, and they come with a M2, M2.5, M3 hole, or with a thread inside. And that's also the same thing with here. We have them starting at 1.6 millimeters, going up to 2, 2.5, 3 M3 and or 3 millimeter types, which is the most widely used ones, yeah. And then, or the M3 is over here, and then we go up to M4 as well. And at the end, we also have a M5 available, but only in one limited height. So, as mentioned, you can have them in a threaded type or a through hole type that you can push through with a hole, with a screw, and then mount it to an external thread. Yeah. So, next point would be about design and processing, and at the end, this is one of the most interesting points here at all. The footprint of the spacer is important to know. How shall I do that? Here you can see the spacer with the external thread, as I just showed it here, and it means that you have the full bottom surface, yeah, which is the solder area. This body has a 6 millimeter diameter and this little center pin, as you can see here. And the center pin is exactly for what it's said. It's for a good centering of the component itself. So you can see here the footprint on the right hand side. It's a solder pad, and we have a hole here in the PCB. And watch out, it's a non-plated through hole, and it's slightly bigger. I mentioned the body is 6 millimeter, while the diameter here is 7.4 millimeter. Of course, this is a recommendation. You can adapt these sizes to your needs. All the tests and all the results that we gained and gathered were achieved with the recommended land patterns. So that is telling you if you use them, and you can get them free from our website for your design. If you use them, then you are likely to achieve the same results. So it's of course important that at the edge of the PCB, or the junction of the PCB to the part, meniscus should appear here all around of the component, and this is where the high retention and the torque comes from. Yeah? And also because there's a very big surface here. So center pin is for accurate precision, as mentioned, and non-plated through hole. That's another topic I want to go dive into in a minute. Stencil recommendation is about 150 microns of solder paste. This maybe seems a little bit big for you, or major point, or an important point is that in your calculation of the solder paste, you need to bear in mind that about 50% of the solder paste is fluxes and actuators, and they disappear during the reflow process. So that's why you need a stencil here, like on the right side. Yeah, you have the pattern field here is the one that needs to be soldered, and you should make sure that no solder paste goes inside the through hole here. So you can optionally get those parts also without a center pin, or later some other parts with the bottom closed also. So looking to the one with the through hole. Now this is a version, the hole is all going through, but you have a thread inside here, as you can see. And the land pattern at the end is only this kind of ring here all around. And this is exactly what needs to be placed here. It means you have a hole in the PCB, and again the bore hole, we call this the shank area, this one, because this is going inside of the bore hole, looking like this. And that's another great benefit of those SMT spacers. You see it's diving in, it's giving it a little bit more strength and an accurate positioning, but on the other hand, it's not coming out on the bottom side of the PCB. Compared to the traditional ones, you always need to have a counterpart where you can screw it in. So that's a big difference and a big advantage, of course. Non-plated through hole, also important here. Stencil is about the same. Here's the stencil suggestion coming up with each data sheet, of course. And also you get them optional with a bottom closed. And yeah, coming to the next thing is why do I insist that we use a non-plated through hole for the SMT spacers? There could occur potential problems. One of the problems you see here, and that's a real cut through a model here. And we saw that, or we can see that this is the solder area. This is the area of the component itself. And we can clearly see that by capillary effects, the solder went up all the sides through the thread. Now imagine how you want to get in a screw into that thread. Yeah? So it will be really hard to screw in, and at the end the solder paste that you find inside of the thread isn't anymore enough here to guarantee the full strength. Yeah? And therefore it reduces the retention of the spacer. And yeah, and there is another point which is at least also important, means that the spacer within the tolerances are pretty tight, but of course the hole needs to be bigger than the component itself to be assembled inside here. So could occur that the component would be drawn outside of the center, and you can see here on the dark side of the moon, yeah, you can call it, there is a gap between the component and the PCB. Means there is no solder, there is no strength. But what is even harder is that you achieve a misalignment, and if you have more than one of the SMT spacers on a PCB and you have a top PCB, so the holes at the end should fit. Otherwise, if they misalign too much, then you cannot fit or hit your screw holes anymore. Yeah? At the end, it's also the same here, that you can have a loss of solder paste when the solder can drop down, and this will lead to reduced retention of the spacer as well. Now, we did a lot of qualification testing, and we spare that to you upon your request. Yeah, just ask your local field sales engineer, and they will be free or frank to give it to you. So you see clearly what we tested and how we tested, and we fully followed the standards. And yeah, so what we found out here is we compared the plated through hole. Everybody would think that plating the through hole would give us more strength. But these tests have proven that this is not the case. Yeah? You can see on the right side here that's the non-plated through hole, and the test results are very narrow together. Yeah? It's almost the same quality, while here it spreads so wide. And to be clear is about the scale. Maybe it's not so good to see outside the number of the scale. If you look at this number, this is exactly here, and at the end this means that this is in this position. So it's clearly and obvious that retention force is better with a non-plated through hole. So now let's have a look on the right angle types. We look at the footprints of the spacers. Yeah, of course we have here these reduced edges. It's this gap here that I want to explain what is the intention for it. Of course, this one is on the side, so this is the solder side, and now this is correct position, and we have that edge over here. So this is like the drawing, and we want to achieve a clear right angle, and therefore if we have this traditionally without this gap, this would lead to misalignment, of course, that the meniscus would appear here, and of course on that side as well, but this would draw the component away from the edge. So at the end, the solution looks more like this. So we still have the meniscus, we still have the strength that the meniscus gives us, but we can achieve a clear 90 degree angle. Maybe hold it on this side. As you can see here, this gives you a clear right angled position. What is different on these right angle types is also that they are not made of steel. These types are made of brass, and as you know, brass is a good conductor and electrical conductor, and therefore you can also use them for electric application. Means you can run current over it. So therefore we also use them in our red cube power terminals. Yeah. So one point here is about the stencil design. We've been talking about that previously. And now here the pattern field, of course, is the fields for the paste, for the solder paste. But there are big corridors here inside. And those corridors are really important. You can't make it one surface. I mentioned that actuators and fluxes need to disappear, and even if they are on the inner side and you don't have those channels, then bubbles would appear inside and voids would appear, and that would loosen the strength of this component. So you can avoid lunkers and voids with it, and also, looking to the round types, you should make clear that no solder paste is going inside of the borehole. Yeah, therefore you need to cover it, and only this areas should be plated. You can see how that looks from the side view. Like, this is the PCB, there is a borehole. And this is the stencil in gray, and the solder paste is going to be filled inside these voids. Yeah? So we need to cover this area so no solder paste can go inside of the borehole. This could look like this, for example, from the shape. What is also possible in your calculation, if you can't achieve enough volume for the solder paste, you can also little bit overprint directly on the solder resist. This will do no harm to your solder resist. During the soldering process, all the solder will be drawn directly on the copper fields. Yeah. So I mentioned before that it comes on a tape with reel, looking like this one, and the machine will draw out the top cover foil, and you will have the component, or pick up the component here by a vacuum. That's vacuum pipettes are used to draw them out. Yeah? So it's perfect for automated processing, and you see this polyimide foil. This is just that the vacuum pipette can really pick up this the component. You see that this can be easily removed afterwards, and this is happening after the process. After everything is soldered, not before the soldering, this would be bad, but after soldering, then you can easily just snip it away. So, and optional, there are types available without this kind of foil that requires a special type of nozzle that's called nozzle. This is a kind of vacuum pipette. It's called nozzle, and yeah, then you can save also that process of removing the foil. In soldering process, that's a standard IPC or JEDEC profile. Nothing is special here. At the end, this means that you can combine those SMT spacers with any kind of other components on the PCB. You don't have to do it in different solder processes. You can all do it at once. Machine don't care, and the oven even also doesn't care what kind of components are inside there. Yeah. It's also 5 times reflow tested, right? 5 times also means that it's not falling down after the 5th time. Also, what we did is a second pass where we first soldered it regularly, then we flipped the board and we did an upside down test. And not only this, we also put in screw or some weight on the components themselves to have more weight to pulling it down, and you can be safe they don't fall down even if they are upside down. So, of course, ROS and REACH needs to be met, and we're still using the exemption 6C. However, it's also possible to have them in totally lead-free, while the price is dramatically higher than currently. But we can switch in a certain time, and I think in the upcoming times we will switch to the zero lead anyway. So some examples here, what you can see here in front of the camera as well is like this one, or the examples I've shown here. We have this nice sample board. You can ask your local field sales if they can spare you one of those packs, and you can test everything by yourself. Here you see a typical application where you have two different boards and supporting a board-to-board connector. You also have the 90-degree angled versions. Here it's a through-hole type and a screw with a nut on the end, or here it's a threaded type where you just screw in. A very special solution is for USB-C, which is very common right now, and there are available on the market some cables with a locking screw, like a single screw or double screw. Maybe you still remember this from your DSOP cables or VGA cables, yeah. And there is a solution where we have some special parts like those. You know, these are the right angle types, but as you can see, the hole is not right in the center. It's done like this, that they are exactly in the same row. So let's come to resume like the economic comparison we did together with an EMS partner. We checked out what is the cost between machine or automated assembly compared to a standard spacer that needs to be installed manually. And here you have the component price for the component here per 1,000 pieces approximately, and of course the assembly cost, which is on the machine, on the pick and place machine, much higher than by hand. Of course, you don't need so much preparation here by hand. So that means assembly cost here is significantly different. Coming from a time calculation, 0.8 seconds is also like a roundabout time that the pick and place machine needs to pick it from the tape and reel and place it to the right point of the PCB. You would need much longer to do that by hand. So compared to the standard spacers and studs, of course you need the counterpart, you need the screw, you need the PCB, and you need to screw in and so on. At the end it means you will need about 30 seconds for such a kind of connection when a PCB is inside or in between, while the machine still is only by 0.8 seconds. Total time for 1,000 pieces then means you need about less than 14 minutes, while you need a whole working day to do that all by hand. And of course the assembly cost here is with the SMT spacers is lower than the standard spacer if you count the labor in. And the break even we can count it here at 765 pieces. Yeah? This is just a compressed seminar. You can ask your local field sales for the full seminar if you're interested in, then we have much more information for you. So this is for me, that's it so far. If you have any questions, yeah, I'm open to it. Silas.
Yeah, Thank you, Götz, for the interesting presentation. Now we will come to your questions. Before we start with the Q&A session, I will share the handout from the presentation from today. You can download it when you click on the black button on the right side. Okay, then I would say we can start with the Q&A session. And the first question. I need a bigger distance between two PCBs. Are there longer SMT spacers available?
Yeah, already mentioned that we have a limitation. Yeah, that's true. The limitation in height is given by the tape and reel cavities. So if you need a longer distance, well, there can be different points. First of all, you can just order a longer type if it's not too long, so we can still put it in the tape and reel packing. Then we can also offer this, or you can have the distance that you really need, and you just pick and place it by hand. That's also possible. Next solution could be that if you want to combine those, you can possibly use a non-threaded version and put it on top to the standard version. So we have 15 to 15 millimeters, so you can achieve up to 30 millimeters just by using two of the components and adding the distance here. At the end, there would be one more, coming back to the standard spacers. You can also use a standard spacer once your SMT spacer is inside the board. You can easily connect it, and there you can achieve any distance that you really need. Hope this answers the question.
Thank you,
So
Götz.
3 solutions, yeah.
Yeah. Thank you. Then I would say next question. How easy are SMT spacers to break from the PCB?
Well, it's not easy. Well, it's all relative, of course, yeah. And I tend to count not in newtons and so on, yeah. I have a new scale for myself, which is boxes of beer. So that means with a standard 3 millimeter type, you can lift up to 2 boxes of beer. Yeah, maybe this answer gives a good impression. Anyhow, we have the test report that I mentioned before. I've shown some extracts of this. You can clearly see what we did and what we tested inside there, and we will be open to disclose this to you and explain it to you, and you see all the values that we achieved with that. Yeah. Hope this answers the question.
Thank you. Okay, then next question. What is the height of the soldering meniscus?
The height of the soldering meniscus. Well, it's not so easy to answer. It's more or less depending on the size of your footprint. That's not a clear measurement, but you have to follow the IPC. It's not the height that counts. It's important that the solder is, you can maybe better see it on this point here, that we have the solder all around of the PCB or of the component. This would be the perfect achievement if it's a closed meniscus. Following the IPC A610, you need to achieve a minimum of 270 degrees, yeah, where the meniscus appears. but to our understanding, the meniscus should be all around closed, yeah, and then you have the best torques and holding forces. Yeah.
Okay, thank you. Then I would say next question. Why a non-bladed hole is used for the center pin?
Still, the center pin has no function in terms of retention. Therefore, you don't need it. And the only purpose for the center pin is to align perfectly, to keep the component perfectly in position. Yeah? So therefore, there's just no need for it. What could happen, and I mentioned it, that we also have components where the bottom is not with this shank type, but it's totally close on the bottom side and coming without a center pin. This could be necessary maybe if you use IMS PCBs, like with a metal substrate on the bottom side. Then you can't use, of course, through holes or any bore holes in there, because this could create you a shortcut. Yeah? And there are possibilities how you can set the accurate position for those kind of components. But this is what we need to discuss with you directly, yeah? So we can give you some hints there as well.
Okay, thank you. Then I think we have time for one last question. That's this one. What is the MOQ for special sizes? Sorry.
At least it's 10K. That's what I know, but it's depending on size and so on, and what type of. But I think it's 10, sometimes 15K, especially if it's very small types like this one. The 1.6 could be higher. The reason for that is that it goes in a galvanic, and the galvanic needs to be filled up. Yeah, it's a rotating galvanic machine, and therefore we need a minimum amount of material inside there. So count on 10K, that will be helpful.
Okay, thank you. Then I would say we are finished with that session. All the questions where we not answer it now, Götz will answer it then via email in the next days. And then I would say thank you, Götz, for your time.
Thanks, Silas.
And for the interesting presentation.
Here, yeah.
And so on, for the answers of all the questions. Yeah, thank you for your attention. I hope you enjoyed it, and hopefully we see us on our next session of the Digital Redays. See you soon, and goodbye.